So you would like to customize your Raspberry Pi. I'll show you how. I usually start with a bare Raspberry Pi and I don't buy additional parts because there are already enough leftover parts from classic PCs around, and it's fairly easy to build a really good Raspberry Pi 5. You can also use spare parts from earlier models of Raspberry Pis. This video is a little bit longer than my previous videos because there is a lot to tell about Raspberry Pi customization. I've divided Raspberry Pi customization to different parts of Raspberry Pi PCB. There are also special videos for each customization option where you can see the details. Here is a bare Raspberry Pi. As you can see, there are quite a lot of connectors, and let's start here. It's a fan connector. It's needed for cooling, but it's not mandatory. You can use this connector, but you can also provide other means of cooling, or you can use other pins from expansion port to run your own fan. So you have pretty much a lot of possibilities how to provide active cooling, or if you are using passive cooling, then you don't need this connector. Let me show you what I did. I actually use this an old fan from a PC power supply. It was a speed regulated fan, so it works from 5 volts on to 12 volts. But I'm running it on 5 volts and enough because it's very big and provides enough cooling without any kind of other cooling assemblies on my Raspberry Pi. If you look at the price of such Raspberry Pi, you can watch it in this video. It's really very simple. You can have the best possible Raspberry Pi 5 running at 2.4 gigahertz. This is a standard speed, and using this kind of fan, it works perfectly. You can watch this video next if you want to see how I did it. So the next possible customization is to build your own case. At the time when the first Raspberry Pi 5s came out, there were not really much cases besides the original case, and I've tried and succeeded to modify a Raspberry Pi 4 case, as you can see in this video. The next possibility for customization is adding a power on button. This is a unique feature of Raspberry Pi 5 because earlier models do not have it. And of course they also don't have any kind of micro button or whatever to be able to start. But here we have two contacts. The square one is a signal and the round one is ground. If you connect a wire and button in the end, so you have to have some kind of a push button, not really a switch, because if you put on a switch, if it is always on, your Raspberry Pi 5 would turn on, and then afterwards, about a few seconds later, it would turn off itself, and the cycle may repeat itself. So you need actually something to press just for a short time to make contact, and then you have to release the contact. So this is a classical power on button as we have them in classic PC. So this is how I did it. It's very simple, and in the background you can see a case that I've already made from a Raspberry Pi 4 case. It was really very easy. You can also watch this in a video, and here you have it. It's a video about how you can make your own power on button. The next thing which you can also do at home is a real-time clock battery. The only thing here which is a little bit more difficult is how to make a proper connector. You can also buy one, but be careful to buy a connector with just the right dimensions so that it fits into this socket like a glove, because if you don't have a good firm contact to your DA1991 power management controller, then actually battery may disconnect while you are moving your Raspberry Pi, and it won't work. But otherwise it's really easy to make it. As you can see here, I've used the classics non-rechargeable battery, and therefore I had to add a diode to prevent accidental charging. The next thing what you can watch, this is this video about adding this kind of battery to your Raspberry Pi 5. I must say that it works perfectly. I've been using my Raspberry Pi now for almost 3/4 of a year, and battery still has 2.8 volts despite the drop from a diode, which is about, doesn't matter, because the lowest voltage that supports running real-time clock operation is yes, it's about 2.2 volts, so no problem here. The next thing we can talk about is video output. If you're using an old TV set, I don't know how many are there around in the world, TV sets without HDMI connections, but nevertheless, if you have a leftover TV set and if you would like to use it with your Raspberry Pi 5, you can easily do it. The same here, you have a round connector which is ground, and you have a square connector, okay, I mean square pin, which is signal. Video signal has a standard 75 ohm output resistance, so it's really easy. You can watch this video to see the details on how you can make your own audio output and how you can make your own video output or audio input to your Raspberry Pi 5. Raspberry Pi 5 is unique, and this is because it's got no analog audio output, and you have to have some kind of additional module to be able to connect an analog device. Otherwise, you can only use an HDMI output, which also provides sound. Here I have another video which is talking about how you can make an analog composite video output. This is a little bit more detailed video which you can watch if you want to do it yourself. It's really easy. Here we have another socket. It's a UART socket. It's meant for debugging, and you can watch this video if you want to know more about how Raspberry Pi 5 works and how it starts and so on. So it's also about using this port, how you can see the debug messages when it's starting and so on. Not many use this port, but okay, if you want to do some tricks with the Raspberry Pi 5, let me tell you that it is directly connected to the system on chip, and even if RP1 microcontroller does not work, this one is still working. Let's see the next option for customization. This is PCIe port. It's just one lane, but nevertheless it gives you so many options. You cannot imagine how many options. So maybe the most popular option is to connect SSD drive. You need a special interface card with M.2 connector where you can plug standard SSD drive. But you can, if you decide to do so, you can also plug in an accelerator instead. And of course, it would have also been possible if there were graphics cards made for Raspberry Pi 5 to put on a graphics card instead. But unfortunately, there are really no useful graphics cards for Raspberry Pi 5. I know that there were some tests with Raspberry Pi with standard graphics cards for PC and interfaces and so on, but so far we usually lack software to make this really fast graphics cards useful with Raspberry Pi 5, so there are really non-commercial products in this field, as much as I know. So here are USB connectors. They give you so many options for additional modules. You can connect an external disk drive, you can connect an external SSD, but okay, you've got the blue ones are USB 3.0 ports, and the black ones are USB 2.0 ports. I suggest that you connect keyboard and mouse to the slower ports, and then you can spare the faster two ports for disks. You can also add USB splitter to any of these ports, and it would also give you another or additional USB ports. So many options, but what you have to be careful about is not to draw too much current from any of these USB ports, because you basically have 5 ampere limitation with your Raspberry Pi if you are using an original Raspberry Pi power supply. Otherwise you can provide more power, but also there are limitations with USB controller and so on. So I must say that what I'm using, and I'll show it later on, it can provide, my power supply can really provide enough power to run almost anything, but of course there are other circuits that are in between. So let me show you. This is my hard drive. It's powered through USB, but if you want to, you can also use a hard drive which has its own power supply, and then you don't have to carry about it. You don't have to care about it. So here is another example what I've done with my Raspberry Pi 5. I've encased it in much larger case, and I've added external internal power button. So there are many things that I've added, and I've made a decent desktop, yes, and I'm still using it, and I like it very much. So what's next? It's expansion port. This really gives you a number of options. You can plug your own modules here. You can also add your fan here if you want to cool your Raspberry Pi. There are actually 5 volt and a ground connector, a ground pin closely together, and you can just use a 2-pin header, female header, to connect your fan. But in this case it won't be speed regulated. You won't know how many RPMs it does have, but it would still work perfectly. You can add additional devices here. You have SPI port, you have a serial port, you have E2C port. So many different protocols are supported in hardware by RP1 microcontroller, and it's real fun what all you can build, what hacks you can build. But of course, here is my example what I did. I actually made a control circuit. It's presented in a special video, and you can watch it. You can remotely start your Raspberry Pi or shut it down or even lock it from other users just by using your smartphone. And there is also a controller for the fan, which must turn off when Raspberry Pi 5 turns off. So it's really an interesting project, and you can watch it in a separate video. This is the one. This is the video. You can find it on my PC USB projects YouTube channel, and it's really interesting, and this way how you can do it yourself. So what's next? Next is a very interesting thing. This is the only PCI, actually it's the only USB-C connector, and I like it very much because first of all it's directly connected to the system on chip, which means that you don't need a RP1 controller operational to use it. And the other thing is that also enables, it can also work as an OTG port. This means that Raspberry Pi 5 can act as a device. The same feature is also available with Raspberry Pi 4. If you install Android 11 or Android 14 or any version in between, you can also use this port like on your smartphone, and it really works. Your Raspberry Pi 5 can be a device to another Raspberry Pi 5. You can transfer files, you can share your connections. For example, you can share your Ethernet connections, and I've already done quite some videos on these topics, but the only condition that you can do this is actually that you cannot really use your standard Raspberry Pi 5 power supply, except if you cut apart its cable and if you pull the data lines out. But I don't recommend you doing it, because you can buy a 5 ampere power supply cable, USB 2.0, which also has all the available data pins. These are the plus and the minus lines, and of course also very strong power supply. So if you use such a cable, which would cost you about €3 or $3, it's very easy to power supply your Raspberry Pi 5 through this port, and at the same time to split the data, to connect data to another device. You just need an adapter which you can make yourself at home, and here is one video that will show you actually how to do it, and it's real fun. I use it every day, and it's a really good thing. There's another video a little bit more detailed on USB-C port, and you might also like to watch this, and I discuss the implementation. I must say that I'm currently using a 30 ampere 5 volt power supply that not only power supplies my Raspberry Pi 5, but it can also supply other devices. However, I can also power, for example, a Raspberry Pi 4 or Raspberry Pi 5 through USB-C port. So the current is flowing to the opposite direction, and it's real fun to see how you can power another Raspberry Pi 5 through this Raspberry Pi 5. I'm not scared of destroying my Raspberry Pi, because the circuit is made actually to provide this kind of current, and it doesn't really matter the direction where it's flowing. It works flawlessly. And when I'm powering my Raspberry Pi 4, Raspberry Pi 5, another Raspberry Pi 4, of course, through this port, I'm also able to directly use all the features with Android that I've mentioned before, and it's real fun. It's real fun because you can share its connections, and if you are using Windows 11, this is a real good thing, because the other Raspberry Pi 5 is simply working as if it was a smartphone, but it has additional features, for example, Ethernet connection. So this is a really good thing to have. So let's go on. These are just 4 pins, connected directly to your Ethernet connector on the right hand side, and you cannot use them without an interface. And an interface is actually power over Ethernet hat. You have to cover your Raspberry Pi 5 with it, and it also provides power to certain pins on the expansion ports. So basically Raspberry Pi 5 gets powered the same way as it does through my 30 ampere power supply, but in this case power is drawn through these 4 pins, and there are also some kind of transformator circuit which extracts power. It can be a number of volts from Ethernet port, and it converts it to 5 volts, so Raspberry Pi 5 can work. So what's this? These are 2 connectors which you can use with a digital camera or a digital display, whichever you want. You can use 2 of each, or 1 of each, or just 1. So it doesn't matter what you plug in. Both can be used, but they are increasingly useful with artificial intelligence, because they provide quite fast way to pump data from your digital camera to your Raspberry Pi 5 for analysis and so on. So they may be useful, yes, they may be useful. But of course there are also other cameras which connect to USB ports, but if you don't want to occupy USB ports and if you would want to have an intermediate controllers that convert data to USB, you can directly connect cameras here. So the last option is to customize your Wi-Fi circuit. It's really interesting one because you can actually add an external antenna. This is a good option because Wi-Fi controller within Raspberry Pi 5 is quite a good one. It enables you to do a lot of hacks, but the problem is that internal antenna is not the very powerful one, and it's very beneficial if you can do it through these pins. And if you watch this video, you'll see how you can do it on Raspberry Pi 3, 4 and 5. So how to add an external antenna. It's really easy to do, but also very rewarding. So that's more or less it, what you can do with Raspberry Pi 5 customization. Here we have Raspberry Pi 4. It also got a number of connectors, but maybe we can start with expansion connector now. It's pretty much the same as on Raspberry Pi 5. Here we can see where you can connect a fan if you want to have your own kind of cooling. It does not have any kind of speed regulation, so this is really the only option how you can connect a fan to your Raspberry Pi 5. So here we have global enable and run pins. These actually are some kind of workaround if you compare them to a power on button. And of course you can, these are much simpler because if you provide a certain signal here, Raspberry Pi 4 may go to sleep mode, or it may shut down itself immediately. So I've also done the video remote power on and off, and you can see in the video what you can basically do also with Raspberry Pi 4. Here we have an analog output, very useful. You don't have to have any additional audio card to provide this output, so it works, I must say. Here are USB ports. The blue ones are USB 3s and the black ones are USB 2s. So here we have just one camera output or input. This is for a digital camera. You can connect just one digital camera, and here is another connector where you can connect just one digital display. So okay, again, it's this expansion port. You can connect variety heads, and some of them or most of them also work on Raspberry Pi 5. Here I also have USB-C port that I've already mentioned. So what is this? This is for power over Ethernet. Also very, you can use almost the same or the same power over Ethernet head, but the only difference is that these pins are not located on the same place as on Raspberry Pi 5 relative to expansion port, so you will actually need a different head to run it on Raspberry Pi 4. So an older version. Here we have Raspberry Pi 3. Also here you can see how you can power it through the Ethernet. You just connect 5-volt pin and ground pin. It works also on Raspberry Pi 4 and on Raspberry Pi 5. So the same audio, analog audio output, USB ports, camera input, display output, and expansion port with basically the same pins as on Raspberry Pi 4 and Raspberry Pi 5. So thank you for watching. Here in the background you can see a Raspberry Pi 5 fully assembled and ready to work So if you've liked this video, please press like and subscribe buttons, and see you in the next video. Bye.